In this module, we're going to talk about how to think about prompt writing, or what some call prompt engineering. We've already talked about how LLMs, despite appearing to be kind of magical, aren't mind readers. They can only really respond to the input you give them. And so if we're thinking about the AI as this literal pedantic junior, we've got to remember there's someone who has encyclopedic knowledge, but zero to very little common sense. They follow your instructions to the letter, nothing more, nothing less. If you leave anything up in the air or gaps in your instructions, they'll just fill it in, and probably not in the way you expected. So if your instructions leave room for interpretation, the AI might fill in all of those gaps some way you don't intend. So in this video, I'm going to talk about how exactly to craft prompts that will get you the results you want every single time. All right, let's get into it. First is choose specificity over vibes, right? You don't want to start with just one-shot prompts. You want to mention the things that matter to you, like the scope of the issue, the requirements you have, any constraints. You want to provide the right and as much context as possible. And you want to talk about the output you're expecting. You want to name that format and be really explicit about it. You also don't want to write a novel or assume that the AI is going to fill in the details by itself correctly. And you want to avoid open-ended creative prompts, especially when you're trying to create a deterministic piece of software. One framework that I like to think about is the research, plan, implement framework. This structure forces deliberate thinking before code generation. First, you have the AI explore the codebase to build an understanding of the problem space between you and it, and then summarize it. Then you have it create an explicit, step-by-step implementation plan with what specific files are involved, maybe some code snippets, and only after a human review of both of those phases does the implementation begin. This helps keep the AI's context window focused and clean at each phase through what you can call intentional compaction. That prevents the accumulated complexity that emerges when you're having kind of an unstructured session or chatting a lot. And we're going to go more in depth into this concept of context engineering in a future module. But the key insight here is that the human review at the research and the planning checkpoints represents the highest leverage use of your time, intervening and catching misunderstandings earlier, which is far cheaper and easier than fixing some cascading errors in massive amounts of generated code. For example, let's say you need a new notification sent via email in your app. You could try to one-shot it with, hey, I need you to add a new notification system to our app that sends emails when users get a new message. This is the classic kind of vibe coding approach, jumping straight into the implementation. The AI will have to make assumptions about your code base, the existing structure, the schema, what notifications mean, what preferences are. You end up with all this context complexity that then translates into code complexity. Instead of this, I could first ask the agent a research task. I need to understand how the application handles user messaging so that we can add email notifications. In Kilo code, we would call this ask mode. But again, we're going to cover the modes in more detail in a later module. Then I might ask architect mode, based on this research document, create an implementation plan for adding email notifications when users receive new messages. Only once I, as a human, have reviewed and sanity checked that plan would I then say something to code mode like execute step 3 of this plan, create the notification service class in source services notifications.ts. In this way, each phase produces a compressed, reviewable artifact. You stay in the smart zone of the context window. Human review happens at each checkpoint, and you can catch bad assumptions in research, which is far cheaper than debugging it in some sort of tangled implementation code. While this concept of research, plan, implement isn't the only way to think about coding, you'll find that other techniques often mimic parts of this structure. Other examples include refining in conversation. This is having the AI write better prompts for you. I do this a lot where I might ask the AI, hey, this is kind of what I want to do. What are the assumptions I should worry about? And what would a good prompt look like for you? Another example is rubber duck debugging. This is something that developers are very much used to, right? We're used to having maybe a physical rubber duck on our desk and talking to it about the problem. Well, the nice thing about doing that with an AI agent is it can actually look at the files with you and challenge your assumptions or help point you in the right direction. You also might try asking the AI to act as a certain role. This gives it guidance to what part of the vector space you want it looking in, right? Is it security? Is it authentication? Is it, as a code reviewer? What is it exactly that you want from it? There's also meta prompting, which is giving very explicit instructions about the output that you're expecting, not just the problem you're trying to solve. That limits the creativity when it comes to what it's going to output, but helps it be creative in how to solve the problem. And one of my favorites is asking for multiple opinions, either from the same model, an agent, or from a different one. You might just in the chat say, hey, I'm trying to solve this problem. Here's the research I've done. What are 3 different ways we could solve it? Let me know what those are before we start coding. And then the agent can come back with 3 approaches, and you can choose the one that matches your conventions and desires the most. The key is to remember that, like Dex Horthy of Human Layer AI says, don't outsource your thinking. You can outsource a lot to AI, but not your engineering mindset. AI is going to only amplify the thinking you've done or the lack thereof.